Here we're going to look at working out the pH of strong acids. Firstly, you may be asked how to define pH in your exam. If you're ever asked to define pH, you simply would write down that pH is equal to minus log to the base 10 of hydrogen ion concentration. And the pH scale is used because there is such a wide range in the concentration of hydrogen ions. And the log to the base 10 basically says, this minus log to the base 10 is basically telling us as the concentration of these hydrogen ions increase by a factor of 10, the pH decreases by 1. We might also, in some instances, have to work out hydrogen ion concentration given the pH value, and that would be equal to 10 to the minus pH. And on your calculator, you would simply type in shift log, and then this 10 to the power button would come up, and then you just type in minus whatever your pH value is. So let's see if we can apply these two very important equations to answer some questions. Firstly, I've been asked to calculate the pH of a 0.150 mole per decimetre solution of hydrochloric acid. Now, first thing to appreciate is you have to know that hydrochloric acid is a strong acid. And as such, if we write the following equation, hydrochloric acid fully dissociates in solution to hydrogen ions and chloride ions, and as such, if I've got 1 mole per decimetre of hydrochloric acid, I'll also have 1 mole per decimetre of hydrogen ions. So what we're saying is that the concentration of the HCl here will be equal to the concentration of hydrogen ions. So if I want to work out the pH of this solution, I would then simply do that pH then is equal to minus log of this concentration of HCl, so minus log of 0.150, and that would give me an answer of 0.82. pH is quoted to 2 decimal places. Okay, we're now being asked to work out the pH of a 1.5 mole per decimetre solution of sulfuric acid. Now, sulfuric acid is a diprotic acid. That means it's got 2 hydrogen ions which can dissociate. And they fully dissociate, being a strong acid, to 2H plus and SO4 2 minus. What that tells me then is if I've got 1 mole per decimetre of sulfuric acid, I will actually form 2 moles per decimetre of hydrogen ions. So when we're asked to work out the pH of a 1.5 mole per decimetre solution of sulfuric acid, my hydrogen ion concentration then is now going to be equal to 2 times 1.50, which is 3 moles per decimetre. My hydrogen ion concentration is double my acid concentration. So I would then do pH is equal to minus log of 3.0, and that would give me a pH of minus 0.48. Whenever we get a hydrogen ion concentration greater than 1, you will get a negative pH value. So there we've worked out the pH of strong acids. We've got a strong monoprotic acid where the concentration of hydrogen ions is equal to the concentration of the acid. And we've got a strong diprotic acid. You have to be aware that sulfuric acid is diprotic, and the hydrogen ion concentration there we can see is going to be double the concentration of the acid. Now, we may get a situation where we have to work out the concentration of an acid given the pH. And in this instance, we would say that the hydrogen ion concentration then is equal to 10 to the minus pH. So in this case, the hydrogen ion concentration then is equal to 10 to the minus, and it says there 1.50. and that there would give me a hydrogen ion concentration of 0.0316 moles per decimetre. And because it's a strong monoprotic acid, if we just go back, my hydrogen ion concentration there is equal to my acid concentration. So the concentration of HCl is also equal to 0.0316 moles per decimetre cubed. We now are being asked to work out the concentration of sulfuric acid that's got a pH of 1.25. And again, first thing we'll do is we'll put the equation that the H plus is equal to 10 to the minus, and the pH there is 1.25. So my hydrogen ion concentration then is equal to 0.0562 moles per decimetre cubed. Now, if we go back and look here, my acid concentration is half my hydrogen ion concentration in a diprotic acid, such as sulfuric acid. So the concentration of H2SO4 is going to be 0.0562 divided by 2. And that there gives me a acid concentration of 0.0281 moles per decimetre cubed. So in this video, we've looked at how we can work out the pH of a strong monoprotic and a strong diprotic acid, and we've also looked at how we can work out the concentrations of a strong monoprotic acid and a strong diprotic acid given the pHs.